Cool. Hello. Testing. Cool. The mic seems to be working. Hello, everyone. I think I would like to start the first workshop for today. Nice to meet you, everyone. I hope that a lot of you were here yesterday and have some sort of an idea of what you're doing. I'm going to be taking a small amount of your time throughout the day, a lot of the time, just to go over some of the basic key concepts that you're going to want to know. So the first one is just to go over and refresh some of the very basic electrical knowledge that you're going to need. This is open to first-year students and unexperienced people. So we want to make sure everyone has a good baseline. If you're like a fourth-year engineering student, you're probably fine. But let's go over some of the basic stuff that is useful to know anyway. So firstly, we have a breadboard. So we've got lots of breadboards around. This is a small one. We've got even bigger ones. They're exceptionally good for prototyping. This is the bad boy you use when you're just trying to see whether something works before you go into any soldering or putting anything in stone. This is the best playground for you to test any proof of concept. So I recommend starting with something like this. You got some components, some sensors, get them working via a breadboard before you do any soldering or anything crazy. So yeah, breadboards, great. They kind of have this system going. So you've got your positive and negative lines generally down the side, and that's the most useful for you to plug in your power. So in terms of the Arduino, if you're using your Arduino or a battery to power lots of things, you probably want to take that red line and put it into one of the rails. It makes it easier for you to keep track of where your power is going. And it also makes it such that you have a lot more space to connect components, because a lot of components will need power. So it's a good way to do it. And then it's the exact same for the negative, because pretty much every single component ever will need to be powered and need to go to negative. So that's why they've left a large amount of space for that. And this is essentially how they're connected. So those yellow lines represent like where the electricity is going. So make sure you're not shorting anything across horizontally when you've got those A, B, C, D, E, F, G, H, I, J columns. They go sideways and they connect sideways. So if you put two components in above each other, they will be completely safely separated, but next to each other, they will connect. And this is really, really useful when you're trying to connect certain things and certain chips and whatever. So yeah, it's the basic circuit if you want to get this working. Just a simple resistor and LED. Make sure you can set this up as a good idea. So I wanted to go over some really basic electrical knowledge because I'm going to assume that not everyone maybe hasn't seen this for a really long time, which is fair because I haven't. Or if you haven't touched this that much before. But anyway, the most important thing that when you're doing this simple electronic stuff is really just Ohm's law. If you master this stuff, you will be perfectly fine. I love this triangle. You can find your own picture of it online. It's very well documented. Essentially, all it's saying is V equals I naught, right? Your voltage is equal to your current times your resistance, and that will always pretty much hold true. It's the fundamental rule and law that allows us to do all of the electronics that we do. And there are like so many things that derived from this simple equation. So yeah, the main reason that this is important for you is you can manipulate the amount of voltage or current going through a component by using this law and by inserting resistors into strategic locations, right? So if you have a component that needs 3.3 volts and you have 5 volts, then you can actually, with resistors, you can make a voltage divider and you can give it 3.3 volts. That's one example of why you would use something like this. And you can calculate the current and exact power draw of any of your components using something like this. Again, a lot of you should be mostly familiar with it, but if you are not, there you are. So then we get to the main sort of application of what this useful formula does, and it's actually a voltage divider. So again, if you are trying to power many different things, you have a 9-volt battery and you need that to be 5 volts, or we'll probably be using that doing that with a regulator. But if you want a specific amount of voltage for any other reason, or you want to change your current, that is my Discord, I'm sorry. Then this is the way it works. So if you can calculate the voltage across any of your resistors, you can actually calculate the voltage between resistors as well. If you have multiple in line, you will have different voltage drops over the course, and they will all always add up to the total voltage. The main concept here is simply that you've got a voltage going out, and that voltage that goes out has to add up again. So when you go through a resistor, you essentially what's called drop a certain amount of voltage, and the amount that you drop is proportional to your resistance. So if you have a really large, beefy resistor that has a lot of resistance in it, you will drop more voltage versus a smaller resistor. And if you pair those up, you can manipulate the amount of voltage you get out on different spots in your circuit, which is really useful throughout any electronic design. So the main formula is just the voltage that you get out. So that's those P1, P2, P3 is the voltage you get in multiplied by your R2, which is the second one over your first and your second one. It's the standard rule. You probably will mostly just be doing 2 resistor ones because it's the most simple voltage divider. But it is to show that you can chain these up and get a pretty interesting effect going if you want to. So yeah, so that brings us to resistors. These resistors, they all have a color code with them. And I literally, I'm a 4th year student. I will always Google this graph without fail because I cannot remember this. I don't use resistors enough in day-to-day life to remember this. So I've put it up here. But the way to read this is essentially if I were to take the resistor that is in this graphic, first digit is a 6 because it's blue, second is red, and then it's black times 1, and then it's gold. So that means that I have 62, and it's times 1, so it doesn't change. It's still 62. If I had times 10, that means it would be 620, for example, I believe. And then, yeah, so, and then you've got the gold line. So that means that this resistor is designed with a tolerance in mind because components are not perfect. So you do have to keep in mind that even though this color code says 62, it's the best to check this with a multimeter, which we do have a few of, and make sure that you are actually within this tolerance because your volt, if for this resistor, it could range between 58.9 and 65.1, which is a little bit of a range, and that's usually acceptable. Most electronics would be perfectly fine if you give it a tiny bit more voltage or a tiny bit less, but there might be, in certain cases, there might be particularly sensitive sensors or equipment that may care about something like this and where you don't give it too much. So yeah, then we get to the multimeters. So I just wanted to go over quickly some of the main settings on them. If you've never used one before, but you can measure the voltage using the settings on these sides. It's a little blurry, sorry, but on the yellow ones, you can actually tell it which order of magnitude you're looking at. That's all those different settings mainly do, is it just lets you look at it in terms of millivolts or volts, whichever one's more useful to you. And this red one will automatically sort of account for that. So all you do is you've got your red and your black line. Red is always power, black is always ground. I recommend actually carrying that convention over into your own circuits when you do a breadboard or anything like that. But yeah, apply the appropriate order of magnitude to your yellow one, and then the voltage will simply come up on the screen when you probe the 2 different ones. So if you have something like a voltage divider, the way that you can check whether it has worked is you get those 2 prongs to get your red and your black, you put them like in between, like over R1, and you check whether your voltage drop was actually accurate, because it will say how much voltage is across that component. And then the same for R2, same for R3, whatever. And you can check that way. It's great for checking resistance, where you actually sit in that 5% tolerance. And it's really great for checking anything. So you've got resistance as well. It's this little ohm symbol, or the ohm symbol over here. Again, it's the exact same. It's got all the different orders of magnitude. So you'll probably be working around sort of that 20K-ish one, pretty middle setting. But yeah, it lets you check your resistances and make sure that it all adds up. Now, the biggest one that I really love to use, and I love multimeters for this function, is what I call continuity tests. So multimeters are a function where if you probe two different locations and you're on the continuity test setting, it will beep really loudly. And it's great because, actually, I wonder if this is on. But yeah, if you get the two probes and you essentially touch them together like that, if you're on the continuity test beeping, it will actually, it will beep really, really loudly. And that means that you have a direct short between those 2 points. Now, sometimes you want a short, right? Like if you have a direct line connection and you suspect that power isn't going through it, then you can test it with this continuity test. And it gives you a lot of really useful information, because it lets you test whether a component is working or not. It lets you test whether a line that you suspect is a short. And it also lets you test different components. And if it beeps across a component, then you know it's not working properly, because it's not meant to. It will only beep if there is a direct electrical line. So yeah, it's good to test whether the multimeter is working. Even if you suspect your multimeter is cooked, you can try a continuity test and see if the resistance in the prongs is actually working properly. But yeah, it gives a loud beeping noise, and it's the best way to sort of do sanity checks. Is my favorite way to put it. Yeah, that's basically probably most of the base knowledge that I want to give you. A lot of the sensors that we're using and a lot of the equipment, we have separate sessions for that as we go throughout the day. But I want to see, hopefully you guys can set up a basic circuit, and we're here to help you out with that as well if you need. And yeah, get started on your product, get started on your idea, because we do have a competition running and it ends tomorrow. So you do not have a lot of time. Good luck with it. I'll be around. Yeah.